How's it going, everyone? In today's episode, we'll be adding a few new movement mechanics to our player character inspired by games like Destiny and Halo Infinite. This video covers sprinting, sliding, and double jumping, and we'll likely return to this topic with more refinements and new mechanics in the future. I've included a link to the sound and animation files you'll need for this episode in the video description below, and with all that out of the way, let's get started. To get everything set up for these mechanics, we'll start by opening up our project settings and adding a new input action called Sprint, binding it to left shift. Back in the content browser, create a new enumerator asset called Movement Mode and open it up. Add 4 new enumerators called Walking, Crouching, Sprinting, and Sliding. Import the slide sound file to your project and create a simple sound cue with it to modulate the pitch and volume. Finally, we'll drag and drop the animation asset FP Sprint Base to an appropriate location in our content browser. Moving over to our weapon blueprints, open up the parent weapon base asset and add a new custom event called Cancel Reload. Then open up its child blueprint weapon basic rifle and add a call to the Cancel Reload event. Use this event to stop the relevant reload montage, in our case FP Reload Montage, and stop all animations playing on the weapon mesh component. Now we'll open up the first-person character BP and add a new variable called Move Mode, using the Movement Mode enum we just created. Move over to the input action events for weapon interaction so we can make changes here as well. Off of Released from input action Fire, add a call to stop fire using our getWeapon function. We'll add a new custom event called Force Stop Fire that connects to stop fire as well. A good example of this being useful could be stopping automatic weapon fire when we start sprinting. While we're in the character blueprint, we'll make some alterations to the walking animation section too. Before playing the footstep sound effects, add a branch that checks if our move mode variable is not equal to sliding, since we don't want footsteps playing during this state. To add extra weightiness to sprinting, after the footstep sound effect, add another branch to check if move mode is currently set to sprinting. Off of the true input, add a call to our dip event with speed set to 4 and strength set to 0.35. Create a new Boolean variable called ADS held and head over to the aim down sight section. Using input action ADS, set this Boolean to true on pressed and false on released. Add a new custom event called enter ADS and connect it to the branch that checks if we're not currently reloading. We'll modify the existing exit ADS event by adding a new Boolean input called fast and use this to drive a branch node. If it's true, we'll double ADS-TL's play rate. Otherwise, we'll continue on to the timeline's reverse input. We'll circle back to the ADS section once we've made some progress on sprinting, but for now, let's move on. We'll start working on our sprinting mechanic by adding a call to the sprint input action we created earlier. Using the pressed output, we'll check if our weapon actor is not currently reloading. If false, use the getWeapon function to call Cancel Reload. Create a new Boolean variable called sprint toggle and add a branch after Cancel Reload using it. Make sure to connect the true output of the first branch to this new branch as well. Use the true and false outputs to set sprint toggle to its inverse, then connect both to another branch also using sprint toggle. Add a new custom event called check stop sprint with a float input called inAxis. Add a call to this event after input axis move forward and use the axis value as the input for inAxis. We'll then add a check to see if this in-axis value is less than 0.5 with a branch. Add a new custom event called Force Stop Sprint and make a call to it before the play input of ADS-TL. The output of this event connects to the same execution line as the branch we just created, then set sprint toggle to false. Off of the true output of the second sprint toggle branch we made, add a call to the Force Stop Fire event, and then add a switch on movement mode node using our Move Mode enumerator variable. Add another new custom event called Force Start Sprint and connect it to the input of the switch node as well. Off of the walking output of the switch node, set Move Mode to sprinting and set the character movement component's max walk speed to base walk speed times 1.6. Add a sequence node and connect a new branch to the first output. This branch checks if our ADS alpha value is greater than 0. If true, call the exit ADS event with fast enabled. Create a new float variable called sprint charge and set it to 0 with the second output of the sequence node. Then add a set timer by event node with time set to 0.1 and looping enabled. Promote the timer handle to a new variable called sprint charge timer and add a new custom event called sprint charge increase, connecting it to the event input of the timer node. With this event, set sprint charge to sprint charge plus 0.1, then check if sprint charge is greater than or equal to 1. If true, set sprint charge to 1 and clear sprint charge timer. Back towards the start of the sprint section, connect both the false output of the second sprint toggle branch and the set sprint toggle false node to a clear and invalidate timer by handle for the sprint charge timer, then set sprint charge to 0. Add another switch on movement mode node and use the sprinting output to set move mode to walking. Reset the character movement component's max walk speed to base walk speed, and add a branch for the ADS held boolean. If true, call the enter ADS event we created earlier. Now we're ready to move on to sliding. Add a new custom event called start slide, and immediately afterwards clear the sprint charge timer. Set sprint toggle to false, and add a dip node with speed set to 0.8 and strength set to 0.6. Add a spawn sound attached node using the slide queue asset we created earlier, using the character's root component as the attached to component input. Get the character movement component's last update velocity with the z value zeroed out. Then get the length of this vector and multiply it by the component's last input vector. Promote the product to a new vector variable, slide direction, set our move mode enumerator to sliding, and set ignore move input on the pawn's controller to true. Add 3 lerps with the following inputs. Use sprint charge as the alpha for all 3, then add a new timeline component called slide_TL. Connect the first 2 lerps to set play rate nodes for crouch_TL and slide_TL respectively. Open up slide_TL, set the length to 1 second, and enable use last keyframe. Create a new float curve called slide alpha and copy the values and shapes shown on screen now. Back in the event graph, add a new lerp to set the character movement component's max walk speed. The A input of this lerp uses base walk speed times 0.65, the B input uses base walk speed times the output of the third lerp we created earlier, and the alpha input uses slide alpha from slide_TL. Use 1 - slide alpha to set the character movement component's braking friction factor, then add an add movement input node using slide direction as the world direction and slide alpha for the scale value, making sure force is enabled. Off of the finished output of slide_TL, set move mode to crouching. Add a new custom event called force stop slide, using it to stop playback of slide_TL, and then connect to the same set move mode node. Set the character movement component's max walk speed to base walk speed times 0.65, re-enable move input for the controller, and set crouch_TL's play rate to 1. Over in the crouch section, add a new custom event called force uncrouch. Add a new boolean variable called crouch key held, and set it to true with input action crouch's pressed output, and to false with its released output. We'll return here in a minute, but for now let's head back to the sliding section to wrap up. After resetting crouch_TL's play rate, set sprint charge to 0 and check if crouch key held is true. If so, call force uncrouch. Last thing we need to do is modify the overridden function canJump. Inside this function, add an AND node after checking our uncrouch timer. Add a select boolean node and set false to true. For the index, check if slide_TL is currently active. For the true input, check if the playback position of slide_TL is greater than 0.25. We'll return to this canJump function later, but for now we'll need to modify our smooth crouching functionality a bit. In our smooth crouching section, add a new switch on movement mode node after setting crouch key held to true. Off of the walking output, set move mode to crouching, and then clear the uncrouched timer. Off of the sprinting output, check if the player is currently falling. If not, call the start slide event. Create a new custom event called forStartSlide and connect it to the start slide call as well. Then connect start slide to the same clear node for the uncrouched timer. Add another switch on movement mode after setting crouch key held to false, making sure to also connect force uncrouch to this switch node. Use the crouching output of the switch to start the timer for check can stand. After the stand up event, set our move mode variable to walking and add a new sequence node. Connect the first output to the reverse input of crouch TL, Then connect the second output to a new branch using sprint toggle. If sprint toggle is true, call the forStart sprint event. On the update execution line of CrouchTL, we're also going to change this multiplier for base walk speed from 0.5 to 0.65 to align with the values we're using over in the sliding section. While we're here, we're also going to add another switch on movement mode node before max walk speed is set. Reconnect the walking and crouching outputs to the set node. The sprinting and sliding outputs will skip updating max walk speed and go straight towards set capsule half height. Now we'll create a useful macro for blocking certain actions if we're currently sprinting. Add a new macro called CanAct with two execute outputs called true and false. Check if mood mode is not currently set to sprinting. If we're not sprinting, connect to the true output. If we are, call forStop sprint and then connect to the false output. Back in the event graph, add this macro before any event called on the weapon child actor to prevent unwanted overlapping actions. Now we're ready to work on double jumping. Still within our first-person character blueprint, add two new integer variables called jumpsLeft and jumpsMax, both with 2 as their default value. Navigate back to the overridden canJump function and add a new input pin to the OR node. Check if jumpsLeft is greater than 0, and connect the output to the OR node. Back in the event graph, set jumpsLeft to jumpsMax after the call to landing dip on the onLanded event. Then add a new sequence node with the first output continuing on to clear coyote timer. The second output will lead to a branch checking if both move mode equals sprinting and crouch key held is true. If this check passes, call forStart slide to serve as the drop slide mechanic. After onJumped, subtract 1 from jumpsLeft and clamp the result between 0 and jumpsMax. Use the result to set jumpsLeft. Then add a branch to check if there's any coyote time left when we jump. If so, play the jump sound effect. If not, skip playing the sound and clear the coyote timer. The last thing we'll need to do in this section is use the event coyote time passed to subtract 1 from jumpsLeft. Otherwise, the player will be able to do 2 mid-air jumps if coyote time is still active after leaving the ground. Now that we're finished with the main functionality of our movement mechanics, we'll make some changes to the animation blueprint to reflect these new features through animation. Starting in the event graph, use playerRef to get and save move mode as a new local variable of the same name. Then add a new function called modify for sprint and open it up. Within this function, modify the existing walkAnimPause variable as shown, and save the result as a new vector variable called sprintAnimPause. We'll also modify walkAnimRote as shown, and save the result to a new rotator variable called sprintAnimRote. Make sure to add this function to the end of the execution line in your event graph. Over in the animation graph, we'll collapse our existing idle pose section into a new state machine called SM Rifle. Later on, this organization will make adding new weapon types easier. Open the state machine's default state, and add a reference to the animation we imported earlier called FP Sprint Base. Set the play rate to 0, and add a new transform bone node for spine 03. Set translation and rotation to add to existing, and bind sprintAnimPause and sprintAnimRot at their respective locations. Bind alpha to walkAnimAlpha and set its interpolation speed to 5. Finally, we'll add a blend poses by bool node with its active value input checking if move mode equals sprinting. Set the blend times to 0.6 and 0.45, and the blend type to cubic in/out. The existing setup for idle walk goes into the false input, and we'll use the transform bone node for the true input. The output of this blend by bool node is what we'll use as the final result for output animation, and now we can check out how everything looks in game. As we can see while playing in the editor, we now have the ability to sprint, power slide after sprinting, and double jump. The procedural animation work we've previously completed blends together with these new abilities, and actions can be interrupted by entering a different movement state. An example of this that I often see in games, which we've also implemented here, is canceling a reload animation by starting a sprint midway through its playback. In the next episode, we'll focus on creating a flexible mantling system, another quality of life feature commonly seen in modern first-person shooters. Most of this system is contained within an actor component, with minimal additions to the player character blueprint to get everything up and running. For the time being though, I hope today's video helped you out in some way. Stay tuned for more tutorial content coming soon. Until next time.